Friends, Nirma Oza here. Once again, meeting for tutorial 19 and the distance series. It is 7th tutorial. In each tutorial, now we have started discussing the problems in distance measurement. To prove that finally distance measurement is not all right for very long transmission lines and big grids, you are bound to go to differential protection. But to prove that, we have to see what are the problems met with. So first problem was direction. Second problem was fault resistance. Third problem was closing faults. And the fourth problem was overloads. And we have discussed these problems, and I tried to with my best efforts, put my best efforts to convince you how these problems are troubling distance measurement. The next problem now, my friends, is power swing. A vast problem. Suffering the power system protection, the distance protection the most. If I say that power swing is not yet fully solved problem, I'm not wrong. To solve this problem of power swing now, people have brought the new, not only power swing, but many more things. People have brought the new wing of the power system protection side, WAMS, wide area measurement systems, right? And for WAMS, we need the PMUs, phase measurement unit, very costly, however, but the maloperations can be avoided. You see, maloperations in the big grid, national grid like India, their population is, 130 crores. There you see, the maloperations are very costly. Therefore, cost of an equipment is, not, it can be done. You can pay for the maloperations, and therefore the PMU is there. What PMU does? PMU measures the voltage and current at one particular place, Ahmedabad, and sends it to Bombay. At Bombay also there is a PMU. PMU Ahmedabad to PMU Bombay, the signal is sent by satellite, geostationary satellites, and time stamping is very important. Time stamping is to be done up to very accurately. Time stamping has to be done. So whatever measurement I do here at Ahmedabad, the same measurement of voltage and current has to be there. Then such problems of power swing can be avoided. But yet, let us not go into those details, because to be very frank, I also don't know WAMS. I have to prepare WAMS, I have to prepare PMU. In IITs, there are separate subjects on WAMS and PMUs. I'm hearing when I go to expert talks that, sir, students and the teachers liked your lecture very much. They will be giving feedback, but it was too high. So we are learning and teaching so cheap things that little higher things we are not being able to understand. And the problem is all those little higher things are in the world, in the professional world, in the industrial world, these higher things are there. Then no doubt person learns by and by. When he goes to the field, by and by he learns. But he is not ready when he ready on the first day. So big companies like ABB, L&T have to train them for one year. And for training, they need a training center, a building. They need staff. They need teachers, trainers. They need equipment to train. So quite a big infrastructure is required. Quite a big cost is there. And then they say that what you are doing, what institutes are doing for 4 years, that we have to spend one more year to train the students. Because teachers are not knowing. When I say power swing, teachers are not knowing power swing also, the name word or the meaning of the word power swing also. So my dear friends, I would request you to whichever subject, not about power system production, machines, power electronics, whichever subject to learn to its depth, teach to its depth. Let your student be masters. Keeping your knowledge with you does not mean anything. Does not mean anything. It will not be for the use of society. It will not be for the use of world. It will not be used for the nation. It will be for the use only if you share your knowledge, if you give your knowledge. And my friends, I am trying to do that at no cost. Power swing. The meaning of power swing is out of step operation of loss, out of step operation or loss of synchronism between the generators. You see, you might be knowing that all the generators in the systems are connected together and are running at 50 hertz. Normal condition, not fault condition. And normal load angle is 30 degree. No problem. But when fault occurs, whenever fault occurs, what happens? That some generators are near the fault, some generators are away from the fault. The generators which are nearer to the fault, their load angle increases by more amount. And generators which are far, their load angle are increasing by less amount. This is known as out of step operation, asynchronous operation, or loss of synchronism, whatever you call it. You can call it pole slipping also. There are many words. And this power swing is troubling. Power swing is there, that's all. Power swing is troubling generators. Power swing is troubling many things. But right now we are discussing distance rays. How power swing is troubling distance protection. That we have to see. For what power swing is, how power swing enters the, or power swing means we are in distance measurement. When power swing occurs, that means when the system is asynchronous, we are measuring impedance. How that impedance travels, what is the locus of this impedance? For that, all mathematical treatment is there. But for here in this video, it would be boring also. And even if not boring, it would be time taking also. And I cannot do that. For that, you will have to buy my module number 4 of power system protection. Adapt Me has many modules: accounts, logistics, commerce, arts, many modules. Out of that, they have modules on Engineering also. In engineering only, right now I think two, robotics and power system protection. Robotics in mechanical side, power system protection in electrical side. In power system protection, I have already given three modules. This fourth module is on way. And if you want to learn the mathematical treatment, you have to buy that, you have to subscribe that. I'm sorry for that. I'm sorry means if anybody wants to learn anything, you have to pay. When you go to college, you have to pay. Pandit Dindayal Energy University at Gandhinagar is charging 2 lakhs of rupees per semester. Sorry, per year. Nirma University is charging some equivalent amount. He said Gujarat, rather this GSET college at Vallabh Vidyanagar is charging some 80,000 or 1 lakh. ADIT is also charging. All self-finance institutes are charging. And students want the degree, therefore they pay. But when I ask for the payment to learn things, people do not take. Up till today, about 80 modules of mine have been sold. Actually, more number of modules should have been sold. But anyway, I cannot force anybody. It is up to you whether you want to learn or not. And therefore, what I started, I wanted to share my knowledge before I die, whatever is with me. My great Guru Dr. Date died in 2002. ऐसा बोला जाता है कि it is told that the big saints, very big saints, when they are on the verge of dying, they give all their energy, all their tap, all their power to the person who is, to the person to whom it can be given, who is to his main disciple. Dr. Date, I don't know whether I'm main disciple. I mean, he was giving to everybody, but he gave me all his knowledge. I mean, I could not gather. I'm not as knowledgeable as him even today. But he tried to give me all his knowledge. I am, therefore, I want to give my knowledge to you. If you don't buy, whatever I can free of cost, I'm giving free of cost. So mathematical treatment I will not be able to do. We will have to rather take it for granted that this is how the distance measured by the relay travels, locus of the distance measurement when power swing occurs. Yes, so this sorry. Yes, so mathematical treatment will not do it. We'll try to understand this figure. Say this is an interconnected system. Some 4-bus system is there. And how many lines? 1, 2, 3. 1, 2, 3, 4, 5. 5 lines are there. So 10 relays are there. If fault does not occur, no problem. But fault occurs at F. And you will agree that R3 and R6 should operate. You see, one of the relay will be that F will be in zone 1, but for another relay it will be in zone 2, so it will operate little later, 0.25 second. Till those 0.25 second, all other relays are also measuring impedance. All other relays are also measuring. Why they are measuring impedance? Because when fault occurs, the voltage has collapsed. And voltage does not collapse immediately. It collapses slowly because generators are very weighty. The weight is high, the inertia is high. So slowly they reduce their speed and the voltage will collapse slowly. Current is high, therefore impedance is measured. If that impedance falls into the characteristic, then the relay will operate. Say for R1, R1 will operate. R3 and R6 should operate and R1 will operate. That is our main problem of power swing. Try to understand. This is our main problem. And yet, more difficult problem will be if R3 or R6 fail, then some other relay will give backup. Say to R3, R2 is giving backup and R7, I think, is giving backup. So backup means 0.25 second more. So then chances of mal-operation due to power swing are more. Some other relay will also operate. And if other relay operates, that line will trip. If that line will trip, then power will be lost. And then the whole system will become unstable. And in the worst case, it can lead to cascaded tripping. The whole power system, whole network may become brown, may become dark. So friends, this is basically a power swing. This is what the power swing is. So the locus of the power swing, as I tell you, we have to agree right now that it is like this. It enters from fourth quadrant. Sorry, I'm sorry. No, I'm sorry. 1, 2, 3, 4. Yes, it enters from fourth quadrant and travels towards origin, travels towards relay. Slowly. Slowly means in terms of cycles. I don't mean in terms of hours. Slowly. If you see this figure, you will see that reactance relay is 100% prone to power swing. It is already seeing the power swing. So reactance relay will operate. So reactance relay should never be used when you are thinking of VHV long transmission line. Right? Second relay, if you talk of impedance, you will see that the power swing locus, if I say that this is the third zone characteristic, then power swing locus will enter the impedance characteristic. And if it enters, then it will operate. And then there will be mal-operation. But more is better because it enters more later. Why I am telling later and earlier? Because it is quite possible that the power swing locus may enter impedance, but it may never enter more, because by that time the right relay has operated and the things have become synchronous. Things have become normal. Now the whole power system is working synchronously. So in that way, more is better. Therefore, I was telling, from start I am telling that when other relays were not there, when numerical world was not there, then Mo was universal, because Mo is the best. Mo is best with reference to direction. Mo is good with reference to fault resistance. Mo is good with reference to overload. Mo is good with reference to power swing also. But if you see, once again, that brilliant version ABB REL 650, that notched relay, it is the best. Power swing will enter that characteristic, the latest. Probably that will never happen, because by that time that power swing might have gone. See. So that is the reason why what I am trying to tell is this characteristic of quadrilateral characteristic is the best with reference to power swing. So once again, for long HV lines and for national grids, big national grids, people are going in for uh, quadrilateral uh, relay or polygonal relay. So often people go for elliptical relay. So often people use more relays also, but two more relays, and they are being rather controlled by carrier. Professor Fadke, as Dr. Date is my grand guru. Dr. Phadke is similar grand guru. He is probably 75 or 82 years old, I don't know. Yet today is giving lectures. And he has, because you see what happened? That we are talking that there are 3 zones. Distance protection is divided into 3 zones. But what is happening? That I have got a main relay at Ahmedabad. First zone is Ahmedabad to Baroda. Right? It 80% Ahmedabad to Baroda. Second zone, Baroda to Surat 50%. And third zone will cross Surat. Now Ahmedabad to Surat is some 350 kilometers. So 300 kilometers, you see, there are every chances for mal-operation due to many problems like overload, power swing, this, that, etc. So we are third zone. When we are drawing the characteristic on the paper, it's okay. And that's what we are doing. That's what teachers are doing. That's what students are doing. They understand the characteristic on paper. They don't understand it this, that 350 kilometer I am talking, 500 kilometer I am talking. Therefore, you see what GEB did, what JETCO did. I'm sorry, I may be wrong probably. I'm not 100% sure. I cannot tell with surety, but I've heard so. But many electricity companies like that avoided third zone. They kept only 2 zones. But then that is wrong because full backup is not available. So Professor Phadke wrote a paper, Third Zone Revisited. You see, you might be knowing that papers are being written. People are craving for paper. They will write paper, and if paper is published, many people will give them congratulations. Ah, very good. They will have to do quite a lot of labor to publish the paper. But to people like Professor Phadke, Arun Phadke, IEEE is inviting him to write a paper. So this paper was an invited paper, Third Zone Revisited. It is available on Google, you can read. It's a very good paper, and such problems like power swing can be solved by that third zone. I mean the philosophy given in Third Zone Revisited also. Anyway, I can tell many things about protection. I am not expert in protection, but because I'm in protection, I'm hearing from here and there. If somebody is good at protection, he will give me news about protection. So that way I learn many things, and I learn many things means I am also a student now. Nobody can say that I'm a teacher. Nobody is a teacher. Nobody is an expert. Everybody is a student till death. Some philosopher said that if you feel that you are not a student, then check your pulse. It has stopped. You will cease to be a student when you will die. So this figure which I was talking about, I'm talking with reference to figure only, right? But what happens that the more or less, say in earlier days, and in earlier days what people were doing, that more or less will enter the rather impedance seen by the power swing will enter the more or less, so more or less will mal-operate. So to avoid mal-operation, people used to use power swing blocking feature. So this is one, I mean, there can be many ways. This is not the only way, but this is one philosophy of power swing blocking. Power swing blocking, power swing point P is coming from right to left. So more relay is there, but I use one more offset more in a OI. Right? So power swing locus will first enter OI, then it will enter Y. Between OI and Y, some milliseconds will pass because you see the machines have inertia, as I told. So now what happens? That power swing locus enters OI. So OI closes. Try to understand. OI1 closes. When OI1 closes, it energizes a timer T. It is in milliseconds. T1 and T2 are NC contacts. When timer times out, T1 and T2 will open out, but till then it is closed. Till then it is closed. Right? So what I was telling, that the power swing enters OI. So OI1 has operated. Timer has started. Right? Timer has operated. Because timer has operated, T1 and T2 has opened out. I'm sorry. T1 and T2 has opened out. It will close after timer times out. That is different. But first it will open out. But Y will also close, because Y will close wrongly, because impedance measured is in, uh, then slowly will come to more relay also. So Y will close. But Y closes, but T is open. Right? I'm 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 so adjusting the timer that before the uh, power swing locus enters Y, T will not time out. So T is open. So T2 is also open. Y2 is closed because it has wrongly closed. But breaker will not trip. So that is true, that my more relay has operated wrongly because of power swing, but breaker will not trip. Yes, but now if there is a genuine fault, then if there is a genuine fault, then impedance measured will cross both the characteristic OI and Y practically simultaneously. OI, Y practically simultaneously. So OI will operate and Y will operate. So both will operate. So T will energize, but it will not time out. So Y2 has operated, T2 has not yet opened, and therefore breaker will trip. For genuine fault, the breaker will trip. For power swing, the breaker. This is known as power swing blocking feature. This is known as power swing blocking feature. I have given the uh, legend also, so that if somebody does not know what is OI, what is 52, what is 50, these are all numbers. These are all internationally known numbers. So with that, friends, my today's talk ends, because no talk should be more than 30, 35, 40 minutes, because otherwise people will get tired. I will give such 150 videos, and in 75 to 80 hours I will teach complete protection. But while we end, if we end with little fresh, with little loose, थोड़ा हल्का सा रह के एंड करे, तो ये थोड़ी हल्की बात है. स्वामी चिन्मयानंद जी ने बोली हल्की बात है मगर वेरी मीनिंगफुल. हैबिट रिमेन्स. हैबिट अपनी टेव है ना, आदत जाती नहीं. हैबिट रिमेन्स. रिमूव एच. Remove H from habit. Then a bit remains. Remove A. Then also bit remains. Remove B. Remove B. Remove B. Still it remains. It does not go. So habit. Don't make anything habit. Don't make anything habit. When it comes, it comes. Behave according to whatever is against you. आपके सामने जैसे चीज आती है ऐसे ही बिहेव करो. Don't make anything a bit that this thing has to be done like this only. Don't make anything a bit. That is what Swami Chinmayananji wants to call. You see, the world is living. The world is not dying. There is no pralay. We are living happily because of such saints. Swami Chinmayananji, Swami Anubhavananji, Swami Brahmavedanji, Bhagwan Buddha, Bhagwan Mahavir. Uh, uh, I don't know how many names can I give? Hundreds, thousand names are there. Because of these people we are living. So this thought, and with this thought, my friend, I will remember my adapt me. Adapt me is very dear to me. It should be by now dear to you because I have given some 35 videos at no cost. So please thank Adapt me, a mobile app through which you can learn things, by paying. But then instead we started giving this in YouTube also, so that in the whole world people can rather understand and learn whatever I know. I don't say that I know everything, but whatever I know, I'm trying to give. Yesterday I was telling that many people who are knowing 100 times more than me are not giving videos. May not be true. They may also be giving videos, right? But then they are also giving, I am also giving. They are also trying, I am also trying. Everybody is trying to educate people. Everybody is trying to share knowledge. Those people who are 10 times better than me, 20 times better than me, and giving these free videos, they are saints. They are very good people. Those people who know 200 times better than me, but not giving anything, hiding, then people do not know their knowledge. That is not of any use. So, because Adapt Me is trying to give you knowledge through me in subject of power system protection, I am thanking Adapt Me to give me a platform. Please, I would request you to please thank, and rather than thanking, please share. I was telling yesterday that this Adapt Me word name should be known to all electrical engineers in the world. So please do that. Till then, thank you and goodbye.